In the linked list, each node will having the 4 fields. Whichever the value that will inserted into the stack at the first, that will be removed out of the stack at the last point. Most of the values of the matrix M into N have a value 0, then it is called as sparse matrix. Two common representation of the sparse matrix, either we can use a array representation or we can use a linked list representation. Hello everyone, welcome to one more session on data structure using C for second semester B.Ca students. In this session, we are going to discuss one more application of array. Myself, Indu J, Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Let's start today's session. What is one more application of array? We use array to represent the sparse matrix. What is sparse matrix? Where the value of zeros are more than the non-zero value. When we are representing anything in the matrix form, we'll be having m rows and n column. When these rows and column combination will give you the number of elements in the matrix, right? So, when we are representing the number of elements in the matrix, more elements of the matrix are zero value rather than the non-zero value. Such type of a matrix are called sparse matrix. Let us have a definition. A matrix is a 2D data object made up of m rows and n column, right? So, how many values will be having? Will be having m into n values. If the most of the values of the matrix have a value 0, what are most of the values of the matrix m into n have a value 0, then it is called as sparse matrix. Why to use a sparse matrix instead of simple matrix? Why we are using the sparse matrix? We are using the sparse matrix for two main reasons. Because it consumes less storage and increase the computation time. When we have only maximum of 0 elements, we are removing those 0 elements and we are giving only the non-zero values into an array. So that reduces the storage space. Instead of storing all the zeros of the matrix, we are storing only the non-zero element of the matrix. So it reduces the storage. As number of the elements has been reduced, the computation time has been increased. There are lesser non-zero element than the 0 and thus lesser memory can be used. Exactly what I just said. And the computing time can be saved by logically designing the data structure traversing only the non-zero element. What we are making with the help of array, we are making that we should traverse only the non-zero element, not the zero element. Thus, we are reducing the computational time of the matrix. So, this is the introduction about the sparse matrix. Then, one more application is representing a sparse matrix in 2D array leads to the wastage of size or the memory. So, what we have to do, instead of storing that in the form of matrix, we are using arrays to store these non-zero values. How we are doing it? With the help of triples, rows, columns and then the values. We are representing the matrix, whatever the matrix we have, we are representing in only 3 columns. That is, one is row, column and then the values. Two common representation of the sparse matrix, either we can use a array representation or we can use a linked list representation. This is a matrix what we have for an example. Let us say how the array representation has been done for the particular matrix. The same matrix is written in this format. The row, whatever the row is there, the row will hold the values. This is our rows, right? Rows of the matrix, that is m into n matrix. So, whatever the value, this is a 0th row, this is a first row, second row and then the third row. When it comes to the column again, these are all the columns what we have, right? How many columns we have? We have 5 columns, that is 0, 1, 2, 3 and 4, right? 5 columns and 4 rows what we are having. How we are going to represent in the form of triplets? What do you mean by triplets? We have to give the row, in which row the value is present, which column the value is present, and what is the value. That is row. Row is the index of the row where the non-zero element is located, right? We are providing which index of the row the non-zero element is providing. See, here we have a non-zero element, that is 3, right? Which row we have a non-zero element? We have a non-zero element at the 0th row. Next, coming into the column, column represents the index where the non-zero element present. Index of the column we are representing. So here at the 0th column, we don't have any value at the 0th row. In the first column of 0th row, we don't have any value. We have a value at the second column of 0th row. So what we are representing here? 0th row, column second, and what is the value we have at that particular position? That is 3. So that's how we are going to represent. Value of the non-zero element is located at that particular index. 0th row and second column. What is the value present? That is 3. Next, what value we have? We are searching in the 0th row itself. At the third column, we don't have any element, and at the fourth column, we have a element, that is 4, right? So 0th row, fourth column, and then the value is 4. That's how we are representing the sparse matrix in the form of triplets. Triplet means row, column, and then the value. Row is what? Row is the index of the particular value where value exists. Column gives the column index where the value exists, and value gives the value of that particular rows and column combination, what the value is there, that will be given. Similarly, when it comes to the first row we have at the 0th column 0, first column 0, at the second column what I have a value as 5. So that is first row, second column, and value is 5, right? So similarly, I have to check for one more value is there in the first row. So at with the position of the column we have, at the third position of the column we have. So first row position column index is 3, and then the value is 7 what we have there as in a row and column value. Next, what we have to check? We have to check at the second row. What we have in the second row? All 0 elements we have. So we are not going to represent anything in the triplet form, right? Coming to the third row. In third row, we have a first column index, we have a value. Third row, first column index, we have a value 2. And then at the third row, second column index, we have a value 6. So we have to represent in the form of triplet. This is how we are going to represent a sparse matrix in the form of array to reduce the space and improve the computational time. Let us see how we are going to represent the same sparse matrix using a linked list. In the linked list, that is a method to using a linked list. In the linked list, each node will having the 4 fields. As in array, we are having a triplet form. Here we are having a 4 fields. What is the one more field we added is whenever we go to the linked list, we should have a next node address, right? So we have already discussed the linked list will be having 2 fields. One is a data field and one is a next node address field. So that has to be added into the triplets. So row, column, value, and next node address will be present. So as row said, it will give you the index of the row where the value present. When it comes to the column, it also gives the index of the column that value is present. Value is nothing but the whatever the non-zero element present at that particular row and then the column, that value we have to take, and address will give you the address of the next node. Because we are dealing with the linked list, this field is mandatory. Without that, we cannot implement the linked list. So let us see the example here. The same sparse matrix we have taken. So what we have given, this is row, this is column, this is value, this is address of next node, right? Address of next node. First we have a 0, 1, 2 and 3. How many rows are there? 4 rows are there. 0, 1, 2, 3, 4 and 5 columns are there. First row we are checking with the first row. In the first row, with column index we have a value, second column index we have a value, the row 0, second column index we have a value, and what is a value? 0 and 2. We have a value as 3. So this will give you the address of next node. So this address will be linking to the one more node, that what we have already discussed. Again, from 0th row we have a 4th index, we have a value. So 0, 4 index, and 4 is a value what we are searching it. That's how we are representing the sparse matrix in the linked list. First we should have a row, then we should have a column index, then we should have a value, then we should have a address. Here last node of the linked list should be pointing to the null. Which is my last node? This is a third row and second column. Third row and second column. Third row, second column, and the value, it will be pointing to the null. That says that is the end of the list. This is how we are going to represent the sparse matrix using the linked list. Let us see one more data structure called stack. What is a stack? Stack is a type of data structure, non-primitive data structure we can say. Yes, it works on the principle of first in, last out. Whichever the value that will inserted into the stack at the first, that will be removed out of the stack at the last point. The stack is a linear data structure where the elements are inserted and deleted from the same end. How we are going to represent the stack? We are going to represent the stack in this format where we have only one opening. Insertion should be done at the same end and deletion should be done at the same end. So this is how we are going to represent the stack. Initially, we will be having no elements in the stack. So we have one variable called top that will be pointing to -1. When we inserted the value, that will be pointing to 0, 1, 2, 3, 4, so on like this. Okay. The position from where the element are inserted is and deleted is called top. From where we are inserting and deletion has to be taken place by only one end called as top. Then in stack, the last data element inserted is the first element to be taken out. Last element inserted is a first element to take out, right? FIFO, last in, first out. Last element what we are going to insert, that will be on the top of the stack, and that has to be removed first to remove the remaining elements. So stack is called as LIFO, last in, first out data structure. Okay, next, what all the operation we can do on the stack? As just now we have discussed, we can do insertion and the deletion from the stack, and also whatever the content is there in the stack, that is called as element. Element can also be called as item. Here each element, whatever the content of the stack, either we refer that element as an item or as an element. The content of the stack is referred as element or the item. So that's what they have shown. One, insertion operation, what we are doing, inserting any element into the stack is called as a push operation, and removing the element from the stack is called as a pop operation. What is insertion operation is called a push operation, deletion operation is called as a pop operation, right? So how we are inserting? We are pushing the element into the stack, and when we are deleting, we are popping the element out of the stack. So let us see the example, the representation, how we are going to represent this stack in the form of array as well as in the form of linked list. Either the way we can represent the stack data structure with the help of array or with the help of linked list. So a stack may be represented in the memory in two ways, by using one-dimensional array using a or by using a linked list. Two ways. What is by using array or by using a single linked list or singly linked list. Representation of stack as array. Let us see how we are going to represent the stack as array. As we have told you, stack works on last in, first out. So whatever the element we are storing in the array, we have to remove the last element first. So how we have to store what are the elements we have in the stack? 12, 8, 21, 33, 18 and 40. These are all the elements which is there on the stack. How we are going to represent? We have to first assign one array. We have to take an array. For that array, which is the last value, have to delete, you have to remove, or which is the first value you have to remove, that has to be at the 0th location. Which is the last value we have to remove, that should be at the 0th location, and which is the first value to be removed, that is at the top of the stack, at the last of the array. So when we are inserting, we are inserted 12 first. When we are deleting, we are deleting the, or popping the last element, that is 40 first, last index of the array. This how we are going to represent the stack in the form of array. When we are representing the stack in the form of linked list, what is the purpose of linked list? Like whichever the data comes first, that will be deleted first, right? So the same stack element, how we are going to represent? We have to delete what first? We have to delete the element 40 first. So this should be at the front end, and this should be, the last element should be 12, should be at the rear end, right? So whichever the data that has to be deleted first, that should be at the front of the linked list, that should be the first node of the linked list, and whichever the element that we have to delete at the last, that should be the last element of the, or last node of the linked list. So we have to delete first 40, so that will be at the top position. So we have given that as a first node in the linked list. Next we have an 18, that will be pointing to the location where 18 has been stored, and the next address will be pointing to the 33 position, means that where the 33 value has been stored. There we will be pointing the next address. This is how we are going to represent the stack in the form of linked list. So for the simple implementation, what all the operations we have discussed, that is push, pop. Let us see the algorithm for those operations, push, pop and displaying the content of the stack. So what we have to do, we have to first check whether there is an element in the stack or not. If there is an element in the stack, then whether stack has a free memory to insert, push the one more element into the stack or not. So how we are going to check? As we have said, we use a one variable called top, right? Top, if top is equal to n minus 1, what is n? The size of the stack. What is n? Size of stack. If top is equal to n minus 1, then we can say that there is no space to insert the element into the stack. See, for example, have a n value as 5, n value is equal to 5, top will be having 0, 1, 2, 3 and 4. Already 5 elements are there. See, elements are 11, 22, 33, 44 and 55. Right, already 5 elements are there. If I want try to insert here, it does not allow me to insert, because what is the size of the stack we have already there, those element is already inserted. So it gives the value as, it has to give one statement saying that the stack is full, we cannot insert the element into the stack. That's what we are checking here. If the top is greater than stack size minus 1, what is stack size? That is n value, n minus 1, then what we have to write? We have to write stack overflow. We cannot insert the element into the stack. So that is condition called as overflow. If this condition is not true, then what we have to do? We have to increment the top value by 1. So here you can check the stack is empty. This condition is not true because we have not inserted any element into the stack, right? So we are coming into the step 2. In the step 2, I want to insert the value 11 or element 11, what I have to do? First I have to increment the top value. Why I have to increment the top value? Initially top will be pointing to -1. What is the initial value of the top? When stack is empty, it will be pointing to -1. First increment the top value by 1, that is by 0. Now what is the top value? Top value is 0. Then put the top of the stack with the element. What is my top of the stack? That is 0th. S of 0th position is equal to 11. We are assigning the element into the S of 0th position. Again, similarly, we have to check for the condition. This has to be done repeatedly to enter number of elements into the stack. Now we are checking whether top is greater than size -1. What is the stack size here? 5 is a stack size, right? So what is the top value now? 0 is a top value. Top is greater than 5? No. Condition false. Again, we have to increment the top value. So when we increment the top value, top will be pointing to the 1. Once we have done with the top will be pointing to the 1, what we have to give? S of 1 is equal to which element I have to insert at the S of 1th position? I have to insert the element 22. That will be inserted. Similarly, we have to do it again to insert one more element. When it reaches to here at the position 55, this condition satisfy. If condition satisfy and it states that stack is overflow, we cannot insert much more element into the stack. So this is how the push operation work, algorithm of push operation. Let us see the C code or the C function for the push operation. Whatever we have done in the algorithm, we are replicating that in the form of C language. What operation we are doing? We are doing the push operation. So we are finding one function called as push. In that push function, what I am checking? The first step, I am checking whether top is equal to stack size -1, that is n -1. If it is equal, what I have to do? I have to say that stack is full, right? So we cannot insert the element into the stack and return back to the main program. If it is not true, this condition is false, what I have to do? I have to increment the top pointer by 1. Either I can do top +1 or I can do top ++, right? Both the way we can increment the top variable. Once we have incrementing the top variable, what is the third step in the algorithm? We have to assign a value for that incremented top value. Stack of top is equal to whatever the element or the item I have to insert into that particular position. That is what we are doing in the C function code. This is only for pushing the element into the stack. That means inserting the element into the stack. Let's see one more operation, that is a pop operation. What pop operation means? We are removing the element out of the stack or deleting the element out of the stack. So pop operation, what pop operation can we do? Algorithm or the steps how we can achieve the pop operation. Check your underflow condition. In the push, what we are checking? We are whether stack is full or not to insert the element. In the pop operation, we have to check whether some elements are there in the stack to remove or to delete that. So that is called as underflow condition. If the stack is empty, we don't have any element in the stack, is it possible to delete any element? No, right? So that's why we have to first check whether stack has some elements within it or not. So that condition is called as underflow condition. How to check the underflow condition? As previously stated, empty stack, the top will be pointing to -1th position, right? So if the top is equal to -1, it says that there is no element in the stack. So what we have to return? We have to return as stack is empty. We don't have any element to delete or pop. So next condition, what we have to do? Next step, we have to decrement the top pointer, because here I have a 55. I am popping it out 55. Now the top position is 4, right? Top position is 4. To make this top position to point the next element or the previous element, what I have to do? I have to decrement the top pointer, right? So we have to decrement. So how I am going to decrement? Top minus minus I have to do. Right, that's what we are doing. Decrement the top pointer by 1, that is top minus 1, or we can use top minus minus. Then after decrementing, what we have to do? If the condition fails, then delete an element. We have to delete the stack element which is there at that particular position. Which position? At the S of 4th position. We have to delete. Let us see the example. So here we have inserted 3 elements into the stack. Now what the initial stack we had for the push operation, now we are implementing the pop operation for the same stack where we have done the push operation, right? Now top L is pointing to this particular location, right? Top is pointing to 33. Now once we call the pop operation, first what we have to check? We have to check whether top is equal to minus 1. Top is equal to minus 1, condition is true? No, right? Top is not equal to minus 1. Then we can go for the second step. In the second step, what I am doing? I am decrementing the top pointer. After decrementing the top pointer, we are deleting this particular element. Then top will be pointing to the first position. Again, I have to decrement the top pointer and delete this particular element. Now top will be pointing to the 0th position. That's how we are going to implement the pop operation. Let us see the C programming code for the pop operation. As we are doing the deletion function, in the stack deletion is called as pop. So we are creating one function called pop. It is returning some value. Why it is returning some value? Because we are deleting the element and returning it back to the memory. So what we have to delete? We have to delete an item. So which we have to take one variable where deleted item has to be stored. So that is of the type integer. What is the first condition? We have to check whether top is equal to minus 1. We are checking whether the stack is an underflow condition or not, whether some elements are there in the stack or not. If the elements are there, what we are printing? We are printing it as a stack is in underflow condition. We cannot delete element from the stack. If this condition is false, then what we have to do? We have to decrement the top pointer by 1, and once we have decremented top pointer, that S of 4, right? S of 4 will be given to that variable what we have initialized here, and return that particular variable to the main memory. That is what the function pop will do. Next, one more function or the operation on the stack is display. To display the content of the stack, how many elements are there and which all the position those elements are there. So in the display function, what we have to do? Either we can call manually like S of 0, what is element is there at the 0th position, element is there at the first position, or element is there at the second position. Can be achieved by using following statement. Just we have to give the printf statement for this particular location or the index value of the stack, or instead of giving this by 0, 1, 2, 3, we can give the printf statement within the for loop. So that's it is going to display the content of the stack. So what we are writing the function for? We are writing the function for displaying the content of the stack or the elements of the stack. So what I am taking? I is taken to give the for loop, right? We have to print all the elements of the stack. So we have to give one loop. We are checking top is equal to minus 1. What is top is equal to minus 1 condition? Says whether there is elements in the stack or not. If this condition is true, there is no elements in the stack, we have to say that it is an empty stack. We are not displaying any contents. Then if this condition is false, then what we have to do? We have to print the content of the stacks are. How many elements of the stacks are there? So that we have to print. How we are going to print? We are using the for loop here. How long we are using the for loop? Till the 0th value, 0th index of the stack, till top index of the stack, we have to print all the elements of the stack. That is print %d and s of I. Starting, what is the value of I? 0. So it will print s of 0 first. Then we are incrementing the value of I. So it will print s of 1 first. then s of 2, like that. For loop will continue until unless this condition satisfied. So this is how we are going to display the content of the stack. So in this session, we have discussed what is a sparse matrix, what is a stack, what operation we can do on the stack, what principle the stacks works on. So stacks works on the principle of last in first out, because insertion and deletion will be done at the same end. Then what we have is operation on the stack, that is push, pop and display operation on the stack. Next we are checking with the algorithm how to implement the complete stack operations. The algorithm to implement the stack operations. So what we have to do, algorithm start with the first step as a start. Initially what we have to do, we have to initialize the top value as equal to -1, assuming that there is no element within the stack, because we have not carried out any push operation, we have not carried out any operation on the stack. We are just initializing the top value as -1. Once in the third step, what you have to do, if top is equal to max -1, max -1 means what? Maximum value, that is n value -1, then what we have to say, we have to print that stack is overflow. Then set the top as ++, set top value is equal to item. What we are doing, we are inserting the item into that particular position. The print item is inserted at the end of the stack, and means at the top position of the stack, then exit. Then what we are sticking here, we are doing it for push operation. This is, you have to call the function push here, and push operation we are doing it, inserting the value into the stack. Then at the step 4, we are doing what? Pop operation. What we have to check in the pop operation, whether there is elements in the stack or not. So we have to check top is equal to -1. If top is equal to -1, there is no element in the stack, so stack is empty, it is in a underflow condition. Else what we have to do, we have to decrement the top pointer. We have to decrement the top pointer by 1, and that value has to be written by using one variable called item deleted. One variable called item deleted, we have to decrement, we have to delete that particular element. Then display function, we have to call the display function here. In display function, again we are checking whether there are some elements are there to display or not. So that we have to check top is equal to -1. If this condition fails, what we are doing, we are displaying the element until the I value become less than the maximum value, right? Then we are stopping our program iterations. So this is what the algorithm to implement the stack operation. You have to write the main function. Within the main function, you have to call the function push, pop and display. We have already seen how the code for the push, pop and display is there. So just write those codes and call that push, pop and display function within the main function, whichever the value is required. Okay, then you will get the complete C programming for that. The application of stack, where all we can use a stack. One is conversion of the expression. When we have a 3 types of expression: infix, postfix and prefix expression. When converting infix expression to postfix expression, we are using the stack. And evaluation of the expression, how to evaluate, when we are evaluating the expression also, we can use a stack data structure, and it can be used for the recursion also. The other applications what we have in the where we can use a stack is to find whether a string is palindrome or not, to check whether the given expression is a valid expression or not. So on that, there are different applications where we can implement these stack data structures. Okay, this is all about the stack data structure. Thank you.